Okay, so now we're going to apply this. Let's pretend that we're going to design classroom furniture for all of Laney High School. So that way, instead of one size fits all, we can have different size chairs, different size lab tables, cafeteria furniture, so that everybody can be more comfortable. Okay, so to do that, we're going to first gather anthropomorphic data, which means data on how big people are. So right here, I have some data from last semester on people's height that we measured in class, and we measured it in feet and inches. First, we need to convert it to decimal feet. So we're going to put in a custom function to do a conversion. So you remember when we convert units, we have given times desired over given. Okay? And so first, we're going to start with the equal sign. Then we're going to have feet plus the conversion of the inches. So we're going to have 4 divided by 12. So that is 5.33 feet. And spreadsheets give us an easy copy and paste function. So if we click this cell and hover the cursor right there, we can click, hold, and drag and copy all that data. Okay. So now we have everything converted to decimal feet. Now we're going to calculate our standard statistical data, mean, median, mode, max, min, and range. Okay. So we're going to use the insert function toolbar, and mean and average mean the same thing. So we're going to first calculate the mean. Okay. Median is the middle of our data set. We're going to look under statistical to get that function. Okay, so our mean and our median are very close. Okay. And we do have some repeating points in here. Just want to calculate the mode. Let's do that one more time. Here we go. Maximum. .16 feet. Minimum. 5.33 feet, and the range is going to be the maximum minus the min, so we type equals maximum minus the minimum. So we have a range of 0.83 feet between the shortest and tallest person. So for standard deviation, we're going to find that again under statistical, and there is standard deviation for population and for sample. We only gathered a sample, so we're going to use the one for sample. But just for curiosity, we're going to put in the one for population as well, just to see what the difference is. Okay, not a big difference, but they are different. So now we want to ask the question, does this data have a normal distribution? So if we graph it, is it going to have most of the data concentrated around the mean with it spread out evenly or symmetrically above and below the mean? So Sheets is a little bit limited on its graphing capability. So, but we're going to work with what we have, and we're going to insert a histogram, which is like a frequency table. Okay, then we have to move that a little bit, pick our data range, and I'm going to customize it so we can look at the dividers. Okay, so does this have a normal distribution? Yeah, for the most part. Most of the data is concentrated around the mean, and it decreases above and below. It's not perfectly symmetrical, but you can still kind of draw a bell curve over it. So for purposes of this example, we're going to say, yes, this is normally distributed. So if we apply the empirical rule, it's going to tell us where most of the data falls. 68% of it will be 1 standard deviation away from the mean, and 95% of it will be 2 standard deviations away from the mean, or above and below. So to calculate 68%, we're simply going to put equals the mean minus standard deviation, and then equals the mean plus standard deviation. So 68% of the data falls between 5.45 feet and 5.92. So that means if we're using this to infer the heights of everybody in the school, 68% of the people will be between these heights. Let's expand it out and find where 95% of the people should be as far as height. And that's 2 standard deviations. So we're going to have equals the mean minus, now we have to multiply the standard deviation times 2. So we're going to put 2 times, oops, let's fix that real quick, equals the mean minus, we're going to put in order of operations, parentheses, 2 star for times, standard deviation, close parentheses. Okay, so that's the mean minus 2 standard deviations. Here it's going to be the same thing, except we're going to be adding. So can we copy and paste and produce our work? Yes. Okay, but instead of minus, we're going to change it to plus. Okay, so 68% of the population should be between these heights. That's 1 standard deviation above and below the mean. And 95% of the population should be between these heights. That's 2 standard deviations below and 2 standard deviations above the mean. So using this data, we could know how big we should design chairs and tables so that they better fit everyone.